Welcome back to the Conference Center, everyone. And before we get started again, I'd like to take just a moment to remind you, you can submit a question to our presenter at any time. Just click on the Enter Question and Submit box at the base of this video console. And you can also open up a copy of the PowerPoint by simply clicking on the button labeled Download PPT. Okay, so it's another day at your plant. You arrive early, get the coffee going, check your emails, and scan your to-do list. Suddenly, your boss, the plant manager, bursts through the door screaming, "Outage!" He wants you to execute a professional shutdown, fast and at a reduced cost. Are you ready? More importantly, is your maintenance team ready? Well, about this time, most planners are probably wishing they had signed up for that maintenance planning and scheduling course when they had the chance. After all, it was specifically tailored to personnel responsible for planning, managing, and executing extended maintenance repairs and outages. If the course brochure mentioned business simulation, even better. Simulation facilitates maintenance planning and scheduling by limiting risk. In addition, business simulation shows results of decisions made in a safe setting instantaneously. How well do the people in your maintenance organization know their roles and responsibilities? Is there a process in place to manage changes and control resources? And what are you doing to minimize risk and maximize communication? Mike Galoff is a strategic account director with the training, consulting, and engineering firm GP Allied. He'll now explain how business simulation coordinates the decisions of many to improve the business process training and spare you the panic of an unexpected outage. Mike, welcome. Glad to have you with us today.
Thanks, Jim. Today I want to give us a short presentation on the learning experience and the ways that it is enhanced through the use of business simulation. So we'll start a bit with a discussion on the use of training in the industrial environment and some of the shortcomings there. We'll talk a bit about specifically around outages and as they're performed in an industrial setting. We'll talk about business simulation and how it can be used to enhance the training experience. And then I'd like to introduce you to one application of this methodology that we use called the outage game, which is used to use business simulation to enhance the learning experience so that people can perform outages in a more effective manner. First, I want to talk a bit about the shortcomings with traditional training. So we think about the classroom setting with the chalkboard and Charlie Brown's teacher blabbing on, and this doesn't work necessarily for the adult learner. In this situation, there's a number of pitfalls that we might see in the classroom. Poor instructional design, worrying about giving out too much information too fast, training only a portion of the process members. And I think this concept of process members is going to be important, especially when we talk about an outage. There's a complicated business process that affects many people across varied disciplines. We'll refer to this later on in the presentation, but it's important that we address all the people that will play a role in this outage process. And many times in the classroom setting, we don't focus on all these people. And finally, we focus more on the lecture itself. We don't allow for time for people to take and apply what they've learned and actually practice and experiment with the new concepts that we've trained them on. And business simulation is a perfect way to overcome this shortcoming. Now, when we talk about adult learners, and that's what we're talking about with training people in an industrial setting, they have higher expectations. Adult learners must be engaged. They're used to having control over their daily schedule and the things that they learn and the activities that they perform. So rather than the traditional high school or grade school training setting, we need to return some of that control back to the adult learners. So this is critical. Second, it's important for adult learners to see the immediate results of what they're doing. They need to be able to take what they're learning and see that they're going to be able to apply it immediately on the job. Again, simulation is a perfect example of a situation where we can use this to enhance that adult learning experience. Let's talk a bit about outages and how we might apply this training model to the typical organization. First, let's describe an outage. A manufacturing outage generally lasts anywhere from 3 to 30 days in duration, generally done annually or perhaps less frequently. During this time frame, all production capability is lost in that area. Budgets to complete this evolution exceed millions of dollars, and in many cases, hundreds of millions of dollars. We see an extensive use of external contractors, and of course, during this time frame, the work that is done is non-routine in nature. This brings a lot of risk to the organization in the form of safety, budget, time, and their ability to start up again upon completion of the outage. It's critical for these organizations to have a process in place to ensure that all people are interacting and communicating properly to avoid and mitigate these risks. The outage process. So there's a dance that we go through to make sure that we are prepared appropriately for these outages. And just the time that we use to execute the actual work is the least of our problems. So we like to divide an outage up into 5 distinct categories. First, the identify phase, where we identify all the work that is to be done and we budget out that work to see if it will fit within our constraints. Next, we plan, schedule, and organize our work. This is where we write our work orders, we do walkthroughs, put together a schedule, balance our resources, order our parts, engage the outside contractors, and order any rental equipment that may be needed for the outage. Finally, just prior to executing the outage, we enter the check readiness phase. This is where we look to see that all of our spare parts are there and ready, that we have the appropriate resources, the permitting, the documentation, that our plan has been communicated appropriately, and that we're 100% ready to execute the outage on the next day. During the execution phase, everything is fluid. So while we're executing the outage, we see a lot of changes that occur. When we get into a certain job, we find that our time estimates were off, that we need certain parts that we hadn't accounted for. Perhaps we have to cancel jobs and add other jobs, reallocate resources. It's very critical that the organization is working with one mind and one voice during this execution phase. And then finally, the review and improve phase. After the completion of the outage, it's critical for the organization to get back together, have an open and frank discussion about what went well, what didn't go well during the execution of the outage, and integrate those lessons learned back into the process so the next outage occurs even more smoothly than this one. Organizations that can address each of these phases and treat them as a process and have people that play a role in each one of these processes will be ultimately more successful during the execution of their outages. So what is a successful outage? Well, there's a number of different ways to measure this. I like to think of it this way. Of course, first, outages must be performed safely. We want to make sure nobody gets hurt and no injuries occur. Second, characterized by a high wrench time. This means that people are actually performing the work and affecting the equipment that's down in the most efficient manner. So the time that we spend looking for the next job, looking for the resources, who's in charge, who can make a decision, where are my parts, these are all negative wrench time. So we want to avoid those whenever possible. And by applying our process, we can improve our wrench time. Of course, the outage should be completed in the shortest possible duration, according to schedule, at the minimum possible cost. And I like to think of them as being incident-free. So of course we have no injuries, but we also have no environmental incidents or no quality problems. And finally, and most importantly, we have an efficient startup with a sustained, reliable operation. So we can restore our equipment to operation, start producing our product, and more efficiently and continually into the future. Some of the issues that we typically see with outages with our customers, first, there's hazy roles and responsibilities. We go into the outage with a plan, and of course as changes get made, it's unclear who can authorize that change or who can make decisions, who's doing what. So there's a lot of people involved, and as I mentioned, a lot of external resources, which only compounds the problem. Oftentimes we have some new, sometimes inexperienced people. And when I say inexperience, I mean lacking a familiarity with the facility. Many times during these outages we see hundreds of contractors brought in to perform the work, and they don't know the location of the lockout tagouts, where certain equipment is located, and the local rules and regulations that apply. This sometimes makes outages inefficient. Of course, scope and integration control. From the moment we start the outage, we find new problems and find new issues, and we have to make decisions on what work will be added to the schedule and what work will be dropped to the schedule. If we're not careful, we'll undergo what's called scope creep, and the duration of the outage and the budget will be lost as we add more and more work to the schedule. Of course, plan effectiveness and schedule adherence are big issues during the outage. Oftentimes we have to make changes, and this is very normal, but the question is, how do we make changes as an organization and communicate those changes to everybody involved, and then look at the impact those changes make on our ability to complete under time and under budget. Many organizations have a lack of process to manage these changes and control resources. So we see people generally late at night making decisions on the spot, reallocating resources, whether those be people or tools or parts, and making a decision on that moment for what they're dealing with, but not giving consideration to how that affects the big picture and the overall plan. So it's important, we believe, for organizations to have a process to manage these changes and decide how decisions are made. Of course, risk management is a critical factor. So we find that by doing a brief risk assessment leading into the outage and trying to predict those tasks that will be more difficult to execute, organizations can be more successful. We have certain tasks that are performed during the outage that we have a lot of experience at, that we've done many times in the past, and that are relatively simple tasks. Those can be done really with little oversight and little management. But some of these tasks that are done just one time, or it's a unique task, or it's very tricky, high potential for overrunning the budget, it's better to look at those, try to predict the problems that we'll have, and then put things in place so that if we do experience those problems, we can recover from them very quickly. And probably the leading problem that people have during the execution of an outage is communication. We have a lot of people that are not routine to the organization, people working around the clock as we're trying to get the most work out of the people and maximize the use of the downtime, and communicating what's been completed, the transitions from shift to shift, and changes to the schedule is always a big challenge for organizations. Those that are successful are the ones that spend the extra time to put together a communication plan and have a process to make sure that everybody understands at all times, and I mean everybody working on the outage, understands exactly where we're at with the plan, what changes have been made, and what their personal responsibilities are as we move ahead with the outage. Okay. Another shortcoming that occurs or related to that is appreciating the number of different disciplines or people that are involved in the outage. So if you go to the typical maintenance manager or the engineering manager and say who's involved with the outage, you'll probably get a list that it consists of maintenance supervision and perhaps the craftspeople and engineering resources, and maybe in some cases they'll even acknowledge the contractors. But there's a lot of other people that touch that process and have an ability to affect its successful outcome. So we like to look at our list as being maintenance, crafts, and supervision, engineering, operations, logistics and production planning, procurement and stores, of course our contractors, quality, safety and environmental, and of course accounting and financial. All these people touch the process in some way, and they have a role to play. The most successful organizations will acknowledge the role that these different disciplines play and clearly define what they're supposed to do and what decisions they make and when they make those decisions. Very important, and this is probably the most important thing. Who's involved, what are their roles, and what are their responsibilities related to the outage. So making improvements to the outage are difficult. If you ask anybody that's gone through one of these industrial outages and has been in charge of them, it's a nightmare. A lot of problems come up, there's a lot of people, and addressing all these problems, it's a difficult thing. There's some common trends that we see playing out that make it difficult to be successful. Number one, the planners are misappropriated. We find that those people that are most successful at this have the planners focused on future work, putting together plans, doing a risk assessment, identifying the resources that will need to complete that work. The problem is the planners are amongst your most skilled people in the organization. So when there's extra work to be done and you need to hand it off to someone that'll get it done properly, then the planner's the guy. He's your go-to guy. Problem is that when the planner's not planning, nobody's planning. So our plans fall apart and we lose efficiency. Remember that all-important wrench time. Second, it's very important to recognize all the players in the organization. Now, it's easy to say and difficult to do. We decide we want to put together a plan and we want to involve the operations people. They sometimes don't recognize the role that they play in the outage planning process, and many times the maintenance people don't consider them part of the process. But very critical that they're involved in the planning and the scheduling and the prioritization of the work that's going to be done. The same is true for our safety environmental resources, for our outside contractors, for our quality control people, and of course our logistics and production planning people who will really be affected by the fact that we've lost all production capability. Another factor to consider is it's difficult to measure the performance. If I were to ask a maintenance manager that's been in charge of an industrial outage, how was your last outage? It'd be difficult to put a number to it. It'd be challenging to describe this without having a back and forth conversation describing what went well, what didn't go well. So with many things, we're able to put a single number or a percentage or a dollar figure. Outages are a little more complex, so sometimes putting together a simple scorecard to measure that success is the key to this. But again, it's difficult to measure, so it's hard to make improvements. Backsliding is rampant in improvements. So many times we see improved outages being performed because of the pure willpower of one or two strong personalities in the organization. While this is good, When those people retire or move on, then the organization tends to backslide. So better to have a strong-willed person that implements a repeatable process that's followed by the organization so these successes can be carried out into the future. And of course, we have a history and cultural issues that contribute to what we like to call improvement paralysis. So we've had people that have been working in that environment for over 30 years, and this is the way things have always been done, and making changes from that way that we've always done things is difficult for them to wrap their heads around. So again, addressing these things as a process, acknowledging the successes of the past, but we're going to do better in the future, and let's focus on the process and not the individual people and the decisions they make. This is the critical success factor. So let's talk a bit about how simulation might be used, specifically with regards to an industrial outage or a manufacturing outage. First, I think this is probably the most important thing that we'll learn out of this presentation is that business process training is difficult. We sometimes use a classroom setting and flip through the PowerPoints and we talk about this process and you should do this and you should do that. And I kind of like to refer to this as committing the sin of should. We talk about what everybody should do or might do or could do, but we don't talk specifically about what they're going to do. So first important factor is being very specific about expectations, roles, and responsibilities. And then through the use of simulation, we use the ability to collapse space and time. Now this sounds a little bit high-tech, but it's really not that difficult. We allow those people to take those lessons that we've just trained them on and apply them in a safe setting where they can make mistakes, they can try things, and they can actually see the results of what they're doing in a short period of time. Let's consider for a second the maintenance planner. The outage is coming up 8 months or maybe a year in advance, and they're sitting down to plan out a job. So they design the procedure that will be followed, assign resources to the job, they look at the spare parts that must be used. So they put together a whole entire job plan. They put this into the computer, and maybe 8 months, a year later into the future, some person that they've never met picks up that work order and executes that work. We all know the job plan's not going to be perfect, but it'll be pretty good. And the person executing the job will do the best they can. They'll make adjustments, they'll adapt, but there'll be problems. The question is, do these shortcomings or these problems ever get communicated back to the planner? The planner is probably off in some other area of the facility doing some other work, and they never get to see the fruits of their labor or the results of the work that they've done. Through the use of simulation, we can collapse that 8 to 1 year time frame so that the planner can put a job plan together, hand it to a guy sitting across the table and watch what they're doing, and they get to understand the theme. What are the things that I'm doing wrong or could be doing better, and how could I apply this back on the job? So this whole idea of collapsing that space, that time frame and that physical space so that we can see the outcome of what we're doing is a critical factor with the use of simulation. So some of the benefits of simulation, people can make mistakes in a risk-free environment. So if I put together a poor work order, or if I decide to not stock so many spare parts, that's okay, because at the end of the day, it's just a simulation, it's just a game. And the worst thing that's going to happen is I get a low score. Not a big deal. But we allow them to take these complex ideas where there's not millions of dollars at stake, but really just a simple game, and allow them to practice and try. So it helps to accentuate or reinforce those complex business processes that we've communicated to them. Second, learning barriers are overcome. As there's no risk involved, people are more apt to practice and try and take that risk and apply what they've learned. Again, think back to that adult learner that wants to see immediate results. If we just give a simple lecture that's sort of abstract, some of that will stick and some of it won't. But if we give the lecture and couple that up with the ability to practice those skills, the learning experience is greatly enhanced. Of course, we get immediate feedback on the cause and effect. We can see the effects of one person's actions on the whole process, and of course that idea of collapsing space and time. The more complex the process, the more appropriate business simulation will be, as we can see the complexities dissolve as that space and time are compressed. So we see a lot of business leaders out there that are using simulation for a variety of different things. Companies such as General Electric, Microsoft, Pepsi, US Steel, Siemens, and Tropicana are all using business simulation in different applications. And there's a theme here, and it seems to be around the complex business processes that are not very easy to get your head wrapped around. We see them applying simulation in different areas such as the sales and marketing process, annual budgeting and cost control efforts, capital planning and budgeting, the design of their proactive maintenance plan, and of course production planning and execution. So they involve all their associates, put together a simulation, we call it a game, and in a risk-free environment they practice some of these tasks that they would normally perform in the job and get to see the outcome of their actions, collapsing space and time again, so that they can see the benefits of applying these new methods or these new processes that are being proposed to them. So it's a common trend in industry to use simulation to enhance the learning experience. Some of the takeaways we see when people do use simulation, of course, it's highly interactive. So as you can imagine, if you've ever been sitting in a training class, the first row to fill up is the back row of the room. And first thing in the morning, people are sitting in the back with their arms folded, not terribly interested in attending the training class. They're taken away from the job, and you can just see in their minds the workload that's piling up in their heads as they're sitting in class listening to this lecture. So they're just not terribly engaged. And if they are engaged, it's probably with their BlackBerry. So by using simulation, we take the people out of that mindset and get them actually doing things. I believe part of their mind thinks back to the child in them that they're actually playing a game, but they're also part of their mind is saying, hey, I'm actually learning something and I can see how this applies. And we see people vocalize that quite a bit. We hear them laughing and joking and carrying on and saying, this is just like what we see at work. This is exactly how things happen there. And you see them try to start to warm up to the idea that, hey, we could do better. Let's try some of these things when we return to work on Monday. Using simulation is an excellent way to make the case for change. So we put some PowerPoints up. We show all these process maps and these complicated procedures, and people, maybe they're skeptical about it. But if we get them to apply them and use them in a simulation mode, playing a game, then they can say, wow, this really did work a little bit. I'm willing to try it. Of course, it reinforces concepts, but I think the most important factor here when using simulation is the momentum and the enthusiasm. People come in and they're a little skeptical. They've been here for 30 years. They've seen this before time and time again, that promises being made that tomorrow's going to be different, we're going to do things differently. But through the fun and the engagement that occurs through the simulation, we see them warm up and start talking about the future. And to me, this is a key factor. When we start hearing people use language like, maybe we should try this, the next time we do this, we'll do this. When they start using that future tense and that language about the future, you know you've got them engaged, they're building some momentum, and good things are coming. At this point, it's important for the managers to step in and kind of guide that enthusiasm, but you really have them at that point. And the simulation is a perfect way to kind of stir up that enthusiasm. So let's talk about one specific application of this. We see many business leaders using the simulation to enhance their experiences through training, specifically addressed to the adult learner. A variety of different business processes can be improved through using this, but let me share with you one experience that we've had, and it's specific to the outage. We call it Outage, the planning and scheduling experience. What we do is we allow people to come in and address and practice that complex outage planning process and execution process that we talked about, those 5 phases. We allow them to practice some of the skill and knowledge that we provided to them, to experience firsthand the wastes and losses that are very common in the execution of a manufacturing outage. And also this simulation highlights the importance of planning principles such as preparation, scope control, communication, schedule integration, and of course risk management. So we think there's a lot of value to the simulation we put together that addresses industrial outages, but rather than listen to me talk about it, let's go take a look at it and I'll show you how the game works. What you see in front of you is the game board. Now we have 4 different departments laid out in different color codes and just given generic names to represent different departments within a facility. Of course we have the crane, which is central to the game, and we have some barriers in front of us here. The way the game is played, we'll put together a team of people. And generally if we have enough people, we'll put together 4 separate teams. So that would be 4 game boards, 4 full teams with a full complement of game materials. And we'll ask them to complete an outage. Now the outage is represented by these work orders. There's roughly 100 work orders or so, and each one has different descriptions on them, different activities that are performed, different constraints, so they require different types of resources to complete the task. We see on the game board that parts can only be moved 1 of 2 ways, either via the crane, and the crane will have to drop the parts in the loading zone indicated on the board, or via the truck, which can be used to move parts throughout the game board. So as the game's progressing, they'll have to move both parts and personnel to the different departments on the game board in order to execute the work orders that they've been given. We see a pile of spare parts in front of us here, and this is just a small sample of what we would actually see. The spare parts that they would actually use would cover most of this table, but quite a mountain of spare parts. And some of them apply and some of them don't, and they'll have to figure out for that particular work order which parts they're going to need to execute that work order. We see our workers here in front of us. They're color-coded in such a way that some of them are electricians, some mechanics, and some contractors. Each individual work order requires a certain combination of resources in order to accomplish that task. And most importantly, we see our lockout-tagout here. So safety is an important factor worked into the game board. We see lockout-tagout fuses here, and depending on the nature of the work order, they may be required to lock out that equipment before they actually perform the work. If the safety monitors catch them in a safety violation, then we'll stop the progress of the game, make them take 2 minutes time out for safety, and all progress is stopped, which is not a big deal. It's only 2 minutes, but when you see the other teams progressing ahead of you, puts a bit of a panic into the team. So this is the game in a nutshell. What we'll generally have them do is the first round, we'll give them virtually no instructions. We'll give them the stack of 100 work orders and say, there you go, have at it. And they'll struggle tremendously. They'll be unclear what they're supposed to be doing, how to read the work orders, how does the crane work. They'll have a lot of problems. And this is typical to an outage that they may experience on the job. And we hear comments such as, this is just like when we're at work. This is the same things that we go through. We'll let them flail at it for about an hour. And then we'll stop them and gather everybody around the whiteboard, and we'll kind of brainstorm for a bit. What went good, what went bad, what could we do better in the future to make sure that the outage worked more smoothly. Then we'll stop the progress. We'll give them approximately 2 hours. And during that 2 hours, they'll take the lessons that we've taught them previously, concepts such as safety, risk management, maximization of resources, roles and responsibilities, single integrated plan, and they'll integrate those into the planning for their outage. So some resources will take and kit and stage the spare parts that we'll need. The crane operator will get practice at driving the crane or driving the truck. And planning personnel will take all of the work orders and develop a detailed Gantt chart that lays out the sequential order of the work orders to be accomplished and balancing the resources so that we don't have a resource overload or underload as we're progressing through the outage. After that 2-hour planning period, we'll start the outage for real. So we'll give them a chance to actually execute the outage, realizing that we have up to 4 teams participating simultaneously, and they'll execute the outage. They'll have various problems as they're executing the outage they'll have to overcome. We'll insert new work orders that they hadn't seen previously, and the teams will be expected to overcome these challenges just as they would on the normal job. Of course, our monitors will be watching for safety violations. If they fail to lock out, tag out, for example, if they knock one of our barriers over, of course, that would be a safety violation. There's a number of ways to do that, and we would ask for a 2-minute safety timeout and basically stop all progress and figure out why this happened and what could they do to prevent this from happening in the future. The team that wins the game is the one simply that executes all the work orders given first. Takes approximately 2.5 to 3 hours for them to execute the game completely and carry out all of the work orders that they've been given. And it gets to be quite tense when you have 4 teams going in the room simultaneously carrying out their work orders and interacting. They all have identical game materials, identical work orders, and a lot of fun interaction happening while they're executing the game. This is the outage experience. Now, we see in these sample pictures here some people practicing the game. So here they are actually putting some plans together and pulling their spare parts out, preparing for the outage. Here we see some people actually putting together a job plan, or a Gantt chart for the outage. Now there's a particular way that this has to be done. There's a limited number of resources. As I mentioned, we only give them so many electricians, so many mechanics, so many contractors, and there's restrictions in there. So they can't get all the work done simultaneously, so they have to put together a plan that maximizes the use of resources at any single time and reduces the resource conflicts that will occur. So the teams that are more successful are the teams that put more time into this planning process. And sadly, what we end up seeing is that some of the people in the classroom put more time into planning their outage for the simulation than they do in the real world. Those things hopefully change after the simulation. They spend a significant amount of time kitting and staging their spare parts in preparation for the outage, practicing some of the more complex work orders, and we actually ask them to do a brief form of risk assessment, looking at those jobs that are more complex and determining what are the things that could go wrong and putting together some sort of risk recovery plan should they have problems as they're actually executing the job. During the execution of the outage, of course, as I mentioned before, there's some key factors that relate back to the actual job. So we simulate lockout tagouts. Of course, the whole idea of the crane being the single resource that can move parts throughout the game board. Now, this is a game, of course, and it's a toy crane and everybody has fun playing with it. But I can tell you through experience, the teams that win are the ones who have the crane moving all the time. Now you ask yourself, how does this apply back on the job? If we look at a big, heavy industrial environment, the cranes are generally the limiting factor on that job. Those organizations that have better control over their cranes and their spare parts are generally those that are better at the execution of their outages. So there's a direct correlation to what we see on the job. And I can kind of tell as an experienced player, those teams that maximize the crane usage, which is a big constraint for them, will be the successful teams. And if we have multiple teams playing, I can always tell who's going to win, being the team that gets all the work done first because their crane's constantly moving. Of course, we've got coffee and sodas floating around the room, and if somebody were to knock one over, that would be an environmental hazard, and we'll generally make them stop working for 2 minutes, clean up the spill, and have some sort of environmental debrief, which seems kind of silly at the time, but as you're watching the other teams progress ahead of you and you're losing time while you sit there and talk about spilling your coffee, it's quite a harrowing experience for the group that's playing the game. As I mentioned, multiple disciplines being applied, mechanics, electricians, contractors, and oftentimes what will happen is in the middle of the game, we'll insert extra work orders that we hadn't given to them initially. And this is very common in a typical outage. We'll find new problems and we'll have to react to them. So we simulate that by inserting new work that they hadn't seen previously and making the groups adjust and react to that, communicate the plan, adjust, drop the low priority work off of the plan. We allow them to ask for extra resources. Of course, if they don't ask, we won't give them to them. But if one group takes us aside and says, hey, can we have another electrician? Then we'll provide it to them. So it reinforces this idea that if we've carefully used our resources and we're maximizing the use of our resources, then going outside and looking for extra resources is fair game and could be the solution to better outage execution. One of the key elements in the process, and those teams that generally do better, are those ones that apply a quality control process to their work. So as they're executing the work order, they assign a person to go back and check the work of the previous person and look for mistakes. Some of these work orders build on each other, so you're building a model along the way, and if you make a mistake on an early work order and catch it later on in the work, you have quite a significant amount of rework disassembling the parts and putting them back together, and of course that costs you time while the other teams are progressing ahead of you. So those teams that are more successful check that work and make those corrections before they become a bigger problem, which is a great lesson to learn when we go back to the job site. Okay, so what are some of the benefits that we see out of these people take away from the outage simulation? First, there's an immediate application. I've spent quite a bit of time in my career talking about to groups of people in a lecture setting about the way the world should work, how we should prepare for an outage, how we should communicate, how we should make changes. And I feel guilty about it, but I've been committing that sin of should. Talking with PowerPoints and flip charts about how the world should work, and these guys shake your hand and leave the room and go back to a world that doesn't change at all. What I've noticed since we started incorporating this simulation is that people see immediately the benefits of what I've been talking about, are able to apply them, and what we like to close the session out with is an action plan. Let's put specific actions in place with names, responsibilities, dates, measurables, so that we can go into the job, back to the workplace, and make these changes happen. And commonly what we'll do is bring one of the senior managers back at the end of the game, let the people explain what they've learned, what they've done, and make a commitment to that manager regarding the changes that they're going to make. Very important. Of course, we let them experience firsthand the typical losses that occur, and this is important. We do this all in a safe environment, close quarters, so everybody can see, looking across the table, the problems that they're experiencing. And this is not something that's usually available in a big industrial setting. The problems that occur at any hour of the day, at the other side of the facility. So this ability to think with one mind as an organization and to understand these problems is generally not there. Through the use of the simulation, people can see these losses, can experience them, and can understand what caused that loss and put things in place to prevent them from occurring into the future. Of course, immediately realization of the benefits, and it really serves to reinforce some of these abstract principles that we talk about in our PowerPoints. The need for preparation, the need for controlling scope and managing changes to that scope, the need for having one single schedule integrated with multiple disciplines, operations, maintenance, procurement, logistics, production planning, safety and environmental, all together. Of course, contractors, we can't forget the contractors, all integrated on that plan, communicated, everybody knows their roles and responsibilities, everybody's bought in on the plan, their priorities are met, they've had a voice in the development of it, and they all understand exactly what they're going to do. And finally, risk management. This is something that people really have a hard time wrapping their heads around, but to do and they think it's really complex and there's some difficult math in there and maybe it's a waste of time. But through the simulation, people get to learn exactly how easy it is to perform a simple risk management exercise and to put simple recovery plans in place so that when they experience problems, they can easily recover. So, what have we talked about today? We've talked about the adult learner and some of the unique characteristics of this adult learner and the high expectations that they have in the learning environment. We've talked a bit about outages and how complex they can be and how much risk is associated with those outages, again, because of that non-routine work and the complex nature of the work. We've got big time, big money, and a lot of people involved. There's a lot of risk involved and a lot of potential for big problems. We talked a bit about how people use simulation to train people and engage people in these complex business processes. And finally, I've given you an example of our application of the simulation. We call it Outage, the planning and scheduling experience, and how it can be used to train people on the complex business process related to outage simulation.
Well, thank you, Mike, and I guess that proves that experience is the best teacher, even when it comes in the form of a game. You know, it's important to point out what Mike Galoff has just demonstrated is a small part of the services GP Allied offers its clients. And to learn more about how GP Allied can help you improve just about any aspect of your operation, take a moment to look for Mike or any of the GP Allied staffers in their booth on the exhibit floor of today's event. They'll be happy to show you some of the other programs and services they have to offer. And while we still have you, Mike, I'd like to see if we can take a few minutes to answer some of the questions that we've collected over the past few minutes. And let's begin with this one. It talks about the idea of simulation in training is very interesting and asks if you can explain how it particularly appeals to the adult learner.
Sure. Well, as we mentioned, adult learners have some specific expectations of a training class. You think about it as an adult on the job, you have a lot of control over your schedule, where you're going to go, what you're going to do. And when you go into a classroom, a typical classroom session where there's a lecture going on, you've really given up all that control to the lecturer. They decide what you're going to talk about, how long you're going to talk about it, when can I go to the bathroom, when are we going to have lunch. This is challenging for the adult learner. Additionally, the adult learner has a lot of things on their mind while they're listening to this lecture. So they're staring at their BlackBerry, worrying about all these things on the job that are piling up while they're sitting and listening to this lecture. So we find that simulation is very important to the adult learner for a couple of reasons. One, they get to practice what we've talked about and actually be part of the training. So they get to make decisions and see the outcomes of those decisions. Really important to the adult learner. And I kind of think that we're replacing the distractions of the BlackBerry and the work piling up with our own distractions as part of the learning experience. So they're very engaged with the game. They're having a lot of fun. They're making decisions. They're putting together their plan. And they seem to forget about the rest of the world while they're doing this. So it's really a great way to get people engaged in what we're trying to teach them.
All right, Mike, let's move to our next one. In your presentation, you promote the simulation as being superior to the more traditional forms of training. Do you feel that simulation is an appropriate replacement for these forms of training, or is there still a place for them in the training world?
Good question. A replacement, no, but a supplement, yes. So there's always going to be a place for the traditional classroom training with the PowerPoints, the chalkboard, and the lectures and the books. This will never go away. But what we can do is come up with a blended solution that enhances the total training experience. So we can communicate the complex principles using the traditional training method and reinforce them using the simulation. So I think a combination of the two provides a better experience. And then we start looking at some of the possibilities that are becoming available to us now through web-based training and internet-based training and video and multimedia. Really, there's a magnificent combination available to us here. So I think it never goes away, but I think it is enhanced through the use of other mediums.
Okay, Mike, this next question reads, you mentioned that the maintenance planning and scheduling process spans across multiple disciplines. Can you help us to understand who you're referring to in this statement?
Sure. A typical mistake that people make is they say, hey, we want to improve our planning and scheduling process, so let's focus on the planner. So we'll even put them on a plane and send them off to some school, and they can learn all these principles about how to plan for a job properly. We put them back into the work environment, and they fail miserably. The reason being is this is not a one-man job. This is not a one-person task that gets performed. It's a process, and it involves a lot of different people. So I like to think that you could take the best planner in the world, if you could find this person, and put them in a typical organization, and if the organization is not participating, they'll fail miserably. They have all the skills they need to do the job, but they're only one piece of the puzzle. An important piece, but not the only piece. So to be effective at this skill, we need to involve all kinds of different disciplines. We need, of course, the planner, maintenance supervision, the craftspeople that will perform the work, the operations personnel, safety and environmental, procurement, logistics, production planning, and of course the contractor people that will be used. And this is a common mistake that people make as well. They don't involve the contractors until the day the actual work is being done. So the more successful organizations bring the contractors in early, engage them in the planning process, and make sure that they understand exactly what it is they're going to be doing when the day comes to perform the actual work. It's a little bit of an investment up front because you're paying for that person to come and scope out the work, but it pays tremendous dividends in the end. So involvement from all these different parties is really important, and I like to reinforce that by saying active participation in the process. So it's not enough to have a meeting and have all these people sitting around the table and 75% of them are sitting there with their hands folded watching the maintenance people have a discussion. The operators, the quality people, the procurement people need to be actively involved in the development of the plan. They need to acknowledge that so that when the plan gets executed, they're bought into that plan, and it's their plan as well, with their priorities, their timelines, and their expectations.
All right, our next question asks what some of the pitfalls are that are associated with the maintenance planning and scheduling process that your simulation is especially good at addressing.
Great question. I think sometimes we make this process a little more complicated than it needs to be. And I like to think that there's 5 simple things that if an organization did, they would see a step jump improvement in their process. So let me just run through those 5 simple things that they could do. Number 1 is have a single plan. So it's very common for us to go into an organization and see that they have a maintenance plan, an engineering plan, an operations plan, several different plans being run in parallel with each other with limited communication between the different plans. Critical that we have one plan speaking with one voice for the organization. Number 2 is have a process to change this plan. So no plan is perfect, and initially we go into an outage, we start the outage, and we find some new element, some new problem, some reason to change the plan. And that's good, that's healthy. We need to acknowledge the fact that we'll have to do that, but how are those decisions made? Who can make those decisions, and how are we communicating them out to everybody in the organization so everybody's still working off that same plan? Number 3 is risk assessment. And I think sometimes this gets a bad rap. People think it's overly complicated, it's fluff, it's consultant talk. This can be a very simple process of going through, listing the specific risks that occur, putting a simple prioritization to those, and taking only those top few that score high, and putting a plan in place, a recovery plan or an avoidance plan to address that risk. It can be done very simply, very easily, and it's a bit like gambling. So the risks that you're addressing, maybe you don't fall victim to them, but if you do, you're going to come out ahead every single time. So I think performing risk assessment is a critical element that's very commonly missing. Number 4, maximizing the schedule. So what we'll see people do is they'll put together a work schedule, and they'll schedule maybe 40 to 50% of their workers' time and say we want to leave some flexibility in the schedule to make adjustments. The problem with this thought process is you can never get that time back. If you're scheduling to 40% of the time, the best thing that can happen is everything went perfectly. You'll gain that 60% back, but you can never win, you can only lose. So I always tell people, let's schedule to the maximum amount of time for every resource, and then let's refer back to that process. When we have to make a change, let's have a process, let's drop off the low priority work, and let's adjust resources from the low priority work to the new work that just came up. But none of this is possible without a process in place, a set of rules, a set of decision-making rules, and people to enact those rules. And finally, the post-event review. So after the outage is complete, After the smoke clears, everybody catches up on their sleep, we're back to operating everything smooth, to sit down and in a formal manner talk about what went well, what didn't go so well, and what changes do we need to make to our process the next time around. There's a lot of self-reflection that can be done and a lot of tremendous learning that can be gained from this, but be formal about it. Structure the meeting, write down the lessons learned, and put together an action plan with personal responsibilities, dates, and formal descriptions of what's going to be done so that we can take those lessons learned and integrate them into our plan for the next time around.
Mike, our next questioner would like you to communicate to us some of the personal feedback that you've received from participants in this simulation. What are they learning? How's it been received? And most importantly, how are they applying it when they return to the job after the training?
Great question. What we typically see is in any training session, we see a lot of skeptical people walk into the room, their arms folded, filling up the back row first, and not quite sure what they're going to learn. As we engage them through the simulation, we see them kind of warm up and talk and vocalize more of what they're feeling. And we hear comments such as, "This is exactly like the problems that we see on the job," or "My boss needs to see this. We need to send everybody in the maintenance department through this training so they can understand what we go through every day." And the funny part of this story is those people that are the biggest skeptics and the loudest, most vocal skeptics end up turning around and becoming the vocal leaders. So we can use this simulation to kind of take that loud voice, that influential person, and then turn them into an agent for change. So I think through this simulation and engaging them and helping them to understand the benefits and what the potentials are, we can change hearts and minds and use them as a leverage point to make real institutional improvements.
All right, Mike, this next question speaks to application. After a group participates in the outage business simulation, what are the next steps? How do they take what they've learned and use it to make a real difference in their work environment?
Okay, well, this is the most important thing to consider. They have a lot of fun, they learn a lot, and they start talking about how things might be different on the job. We can call this a great awakening or an aha moment for the organization, but it's incumbent upon the leaders in that organization to take this energy, turn it into an actionable plan, and keep the momentum going. So the most successful organizations coming out of this training simulation are the ones, and we lead them through this, are the ones that put together a very specific plan, taking just a small amount of the lessons learned, maybe 1 or 2 or maybe 3 things that they could do better based on what they've learned during the simulation, putting that into an action plan and getting the people that participated in the simulation to be leaders on that plan, to take specific responsibilities for executing those actions, and to reference back to the simulation whenever possible as they're making this change in the organization. So I see it as a awakening or an aha moment or a kind of a light bulb going off that re-energizes the organization and kind of gives them a track to move forward upon.
Mike, we'll have to stop things there. I want to thank you very much for being with us today, and we'll let you get back to the GP Allied booth now, or maybe we'll see you at the networking lounge a little later on. Thanks once again.
Thanks, Jim. My pleasure.
When we end this session, I would ask you all to please take just a moment to complete the evaluation form that will appear on your screen. We need your feedback to help us improve the quality of our Global Spec E-events. And also, be sure to join us again at 3 o'clock Eastern Time when Jeff Vassell of ABB will take the stage to explain how process and power automation can reap economic rewards in managing your plant utilities. Watch for the alert scrolling along the bottom of the screen. That'll let you know when we're about 5 minutes before the start of this presentation, so you certainly won't miss it. In the meantime, take this time to chat with your peers and industry experts gathering in the exhibit hall and networking lounge, and we'll see you back here at 3 o'clock Eastern.